Hello, my name is Allison Hill. I'm in Physiology 1010, and the date is 8/21/2020. Hi guys, the topic that I chose today is determination of gender, genes versus hormones. The first slide that I'm going to talk about is how genes determine our gender. There are 23 total pairs of chromosomes in the average person. 22 of those pairs are autosomal, meaning they are non-sex chromosomes. These determine all other factors of our genetic makeup except for our sex. One of these pairs, the last pair, is the sex determining chromosome. If you look in the picture at the bottom, you can see 22 of those pairs, and then in the little blue box is the 23rd pair. In the picture, it depicts an X and a Y chromosome. So this person would be a male. If it was two X chromosomes, the person would be a female. If there's a Y chromosome present in any of the chromosomes, the genetic sex will become a male. Next, I wanted to talk about chromosome pairing and some of the issues that can come up in chromosome pairing. So the presence or absence of a Y chromosome determines that it is male, even if the zygote also has multiple X chromosomes. So if there's two X's and a Y, that person will become a male. Even though there's two X's, if there's any Y's in the genetic makeup, then it will become a male. A zygote that inherits only a Y chromosome, so it'd be YO, will die because an X chromosome is absolutely needed and is essential for our genes. In the absence of a Y chromosome, an embryo will develop into a female. For this reason, a zygote that only gets one chromosome, XO, they would have Turner syndrome. And I inserted a picture in the bottom left hand corner to point out what Turner syndrome is and what people develop whenever they have Turner syndrome. Two X chromosomes are absolutely needed for normal female reproductive function. So once the ovaries develop in a female fetus, one X chromosome in each cell of her body is inactivated and condenses into a clump of nuclear chromatin known as a Barr body. Next, we're going to talk about the SRY gene. This is a sex determining region Y. It is found on Y chromosomes only, and it leads to the development of male phenotypes such as the testes. The SRY gene, located on the short branch of the Y chromosome, initiates male embryonic development in the XY sex determination system. If an SRY gene is not present in a chromosome, this means that ovaries will form instead of the testes. So you can see a picture of a chromosome here, and the SRY gene will just be on one of the little short branches of the chromosome. So all males have an SRY gene, but females do not. Next, we're going to talk about hormones and their determination of gender in the male. So as we talked about before, the SRY gene must be present in males, and the testes secretes 3 different hormones that influence development of internal and external genitalia. So the first one is anti-Müllerian hormone, also known as ANH. The next one is androgen, and the third one is dihydrotestosterone, or DHT. We'll talk a little more about Mullerian ducts versus Wolffian ducts later, but I wanted to point out that the SRY protein in a male embryo directs the medulla and um, the gonads, and they develop into the testes. Then the anti-Mullerian hormone from the testes causes the Mullerian ducts to disappear completely. Testosterone's job is converting the Wolffian duct into seminal vesicle, vas deferens, and epididymis. And then DHT controls prostate development. So they all play an important role in the testes and male development. Next, we'll talk about hormones in the female. And so, obviously, females have no SRY gene present. Um, this affects the AMH, testosterone, and DHT. So if you look in the picture, you can see more information about that. Gonadal cortex becomes the ovary in the absence of the SRY protein and under the influence of female specific genes. So if the SRY gene is not present, obviously it can't form a testes, so it forms the ovaries in a woman and a girl. In the absence of testosterone causes the Wolffian duct to degenerate, so it just disappears. And at birth, the absence of anti-Mullerian hormone allows the Mullerian duct to become the fallopian tube, uterus, and upper part of the vagina. So we've talked about the internal differentiation between males and females. I wanted to point out the external differentiation. And so if you look at this, if you look at this picture, you can see that at 6 weeks, the embryo in a male and female looks exactly the same. You can't tell if it's going to be a male or female. But then between 7 and 10 weeks, the fetus begins to form external genitalia, depending on what hormones it has. So if it has the SRY gene and the male hormones, then it will obviously grow male external genitalia. And then if it has no SRY gene and female hormones, then it will grow female genitalia. So I wanted to point out that in females, the absence of androgens cause female genitalia to form, and DHT causes male external genitalia to form. And lastly, I just wanted to talk about secondary sex characteristics of the male and female. So we've talked about internal and external genitalia, and then as we know, males and females also have different secondary sex characteristics as well. These include obviously more muscle mass in a male, and pubic hair, testicular enlargement, and lots of underarm hair, and just different features in the male. And then the woman will develop breast, and she will have an increase in fat mass, and her hips will widen in order to have babies later on, and just a few different things that the male and female have. So in males, the androgens are the hormones in which that causes the male secondary sex characteristics to form, and in the female, estrogen and androgens also cause the feminine body features to form. So that is all that I had for you guys. I hope this was informative and that you learned something. I know I did, and thank you for watching.